We're going to use algebra tiles to help us solve and model our algebraic equations. First, always start by looking at the legend to determine which color represents your positive and your negative tiles. So for our first equation, on the left-hand side, we have x plus 4 tiles equals 3. We want to isolate the variable, which means we want to get the x all by itself. So to make 0 with 4 positive tiles on the left-hand side, we need to add 4 negative tiles. When we add the 4 negative tiles to the 4 positive tiles, that makes 0, so we can get rid of those. And because we added 4 negative tiles on the left-hand side, we have to do the same thing to the right-hand side to preserve equality in the equation. And that also gives us 3 pairs of 0 tiles. So to represent that with my equation, originally on the left-hand side I had x plus 4, and then I had 4 negatives added on to that side. On the right-hand side, I originally had 3, and I put 4 negatives on that side as well. And once all our 0 pairs are gone, that leaves us with a solution of x equals -1. And we always want to check or verify our solution to make sure that it is correct. So start by copying down your equation, and then replace your variable of x with your solution of -1. So -1 plus 4 equals 3. And then 3 on the left side and 3 on the right side. And when the left and right side are equal, that means we have the correct solution to our equation. This model is showing the equation x plus 2 equals -5. We want to isolate the variable x. Right now there are 2 positives on the left-hand side with that variable. So to make 0 with the 2 positives, we're going to add 2 negatives. When we have 0 pairs, we can get rid of those. Because we added 2 negatives on the left-hand side, we also have to add 2 negatives on the right-hand side. There are no 0 pairs to get rid of on the right-hand side. So this equation step would look like x plus 2, and then we put 2 negatives to make 0, and the right hand side we had -5, and then we put 2 more negatives to preserve equality. Once all our 0 pairs are gone, we're left with a solution of x equals -7. We'll recopy down our equation and then replace the variable of x with a -7 to check our solution. -7 plus 2 is -5. So the left hand and the right hand side are equal. That's the correct solution to our equation. This model shows the equation 3x equals -12. To isolate the variable x, we want to split those 12 tiles up equally into the 3 groups. So I'm dividing them up into 3 equal groups. On the left-hand side, I split the 3 x's up into 3 groups. Same thing on the right-hand side, I split the -12 tiles up into 3 groups. In one group of x, there would be 4 negative tiles. And we'll check our solution, recopy down your original equation, replace the variable of x with your solution. 3 times -4 is -12, so the left hand and the right hand side are the same, and that's the solution to our equation, x equals -4. The equation modeled in this example is 3x plus 1 equals 7. The first thing we want to do before we can isolate our x variable is to make 0 with our +1 that's on the left hand side. So I've added one negative tile to make 0, and I did the same thing on the right hand side. I added one negative tile, and that will make 0 with one of the 7 on the right hand side. To represent that with my equation, 3x plus 1, and then I put a negative 1 to make 0. On the right hand side I had 7, and I put a negative 1 to make the equation still preserve equality. Now we have 3 x's on the left hand side equal to 6 on the right hand side. To isolate just one x by itself, I'm going to split those into 3 equal groups. So I'm splitting up or dividing into 3 equal groups. And one x tile would have 2 positive tiles with it on the right hand side. To verify our solution, we'll copy down our original equation, replace the variable x with a 2 in our solution. So 3 times 2 plus 1, and we'll see if that equals 7. 3 times 2 is 6 plus 1, so 6 plus 1 equals 7 on the left hand side and 7 on the right hand side. So that's the correct solution to our equation.